Hello everyone, I'm Tim Gilding, Manufacturing Consultant on the team at Graitec Professional Services, and I'm here to present to you some of the features which make Autodesk Inventor 2015 such a powerful tool for creating some of the world's best products. Over the next hour, I'll take you through a selection of features and workflows which highlight the flexibility and efficiency of this package. We will go through multi-body modeling, frame generator and bolted connections, BIM tools for architectural models, and visualizations within Inventor. I'll start by explaining the meaning of digital prototyping and what it can do for your business. The manufacturing industry is quite diverse and is comprised of multiple segments and sub-segments. We recognize the fact that business drivers and challenges that companies face in the industrial machinery segment, for example, are different than those experienced by companies in the consumer products segment. However, the reality is that whether you're manufacturing conveyor equipment or dentist chairs, the challenges manufacturing companies face in bringing products to market have more similarities than differences. The common challenges we have heard from our customers include meeting customer expectations for product complexity, reliability, affordability with ever tighter delivery schedules, compliance with regulations, and increasing competition in today's global marketplace. In a recent study conducted by Tech Clarity, they identified some of the common business strategies manufacturers are putting in place to address these challenges. Not surprisingly, product differentiation through innovation and customization, along with competing in the global marketplace, are the top 3 business strategies for growth, as you can see from the study conclusions here. The study then focused on the top performing companies and what they are doing to achieve superior financial performance. In this case, the top performers were defined as those companies growing their revenues and profits 2 to 2.5 times faster than the average companies in the study. One common characteristic that stood out clearly is in the product development process. The companies who have achieved superior financial performance in today's ever-challenging global competitive marketplace have adopted digital prototyping extensively, not just in engineering, but throughout the entire process of developing new products, from design and engineering, through test and validation, through manufacturing and production. Furthermore, these companies leverage a comprehensive data management approach that allows multiple people and departments to collaborate on a single digital product model while maintaining the appropriate level of control and change management. Digital prototyping gives conceptual design, engineering, manufacturing, and sales and marketing departments the ability to virtually explore a complete product before it is built. The traditional method of product development can make digital knowledge of the product hard to come by in the early conceptual phases, when the flexibility to make changes is the highest. As the data is passed over to the engineering discipline, incompatibilities can result in a decrease in productivity, which drives up costs as the data is recreated. Discovering design flaws in later stages can drive down productivity while further driving up cost. Constructing physical prototypes to establish the product knowledge needed to refine and ultimately manufacture the product results in dramatically increased costs and delayed time to market. However, the decreasing cost of 3D printing or rapid prototyping is allowing the manufacturing industry to produce physical prototypes earlier in the process, and ties in well to the digital prototyping workflow. The advantage of digital prototyping is twofold, because more product knowledge is available earlier in the process, because data loss is minimized or eliminated as you move downstream, and you don't have to construct as many physical prototypes. Productivity is dramatically increased while costs are dramatically reduced. and at the same time, your ability to innovate is dramatically increased. This means you can get a better product to market in less time, resulting in increased revenue and market share as your customers choose your product over the competition. Next, we'll jump into Inventor and I'll show you some of the features which relate to digital prototyping process. Traditionally, 3D modeling was thought of as a process where the user would create a single part, fully detail that single part, insert it into an assembly, create another single part, fully detail that, insert that into the assembly, until the point where they're ready to create a drawing. This process is known as bottom-up modeling, creating the small stuff first and working up to the bigger picture. The advent of multibody modeling has led to top-down modeling, allowing us to create the big picture first, digging down into the smaller aspects later, and creating the detail. Multibody modeling allows us to model the entirety of an assembly in one part file, creating relationships and dependencies which make the part flexible and adjustable. This leads to easily adjustable assemblies, as multi-body parts can be exploded into multiple parts, which drop into assemblies and sub-assemblies. This hydraulic ram was created as a part with 3 separate bodies, then exploded into individual parts and dropped into an assembly. Inventor has a tool which performs this in one single command, no matter how many bodies exist in the part. The 3 individual bodies, in this case the cylinder, the seal, and the piston rod, were all detailed individually, adding features like edge radius, groove detailing, and material definitions. Because all the bodies are interrelated in the original multi-body part, I can open the original part file, change a dimension, in this case changing a parameter called stroke. Because of the way I've set up this file, a lot of the parameters are interrelated, and when I change the stroke, they change to suit the new stroke. I can update the file, make sure I'm happy with it, jump back into my cylinder assembly, update the file, and everything updates in accordance with the part file. All the relationships are retained, all the constraints are retained, and the file is very adaptive and flexible. We can even create intelligent assemblies which update aspects such as limits of movement. The stroke in this example is actually defined by the cylinder multi-body part. In here, our stroke is 400 millimeters. In our assembly, I've linked that parameter through, and our stroke is the same distance. If I change that in the original, to 450 millimeters, update the part, and update the assembly, we'll see that the stroke has updated to 450 millimeters in accordance with the multi-body part. This workflow can seriously decrease rework time by creating a domino effect in part updates. The traditional bottom-up method would mean each of the components in this assembly, in this case the cylinder, the seal and the piston rod, would have to be updated individually and then double checked to make sure the changes aren't clashing with other parts in the assembly. You can imagine this would take quite a lot of time. Where possible, I strongly recommend adopting the multi-body top-down modeling method to reduce time spent adjusting components in an assembly. The next thing I'm going to show you today is the frame generator, a feature in the design accelerators sector of Inventor. Frame generator uses a sketch or edges of a part to place extruded sections of metal, plastic or timber, giving you a fast and fluent method to create framework and other various parts. What we have here is a simple set of sketches in a part, inserted into an assembly file. Frame generator allows us to use these sketches as construction skeleton to place the frame members of our structure. By choosing elements of our sketch, I can insert components from a huge predefined library using different standards, different families, specifying the size of that specific section, and choosing a material for that part as well. Furthermore, I can choose an orientation, and slowly build up our structural model. Frame generator creates what looks like a subassembly that contains a series of components which will build up as we create our assembly. Frame generator also includes a number of tools to adjust features such as end treatments, like miter joints, we can shorten or extend our pieces if we need to. For example, we can add 100mm to the bottom of this piece quite easily, or maybe a meter. We also have additional tools such as notch to take out a section of a part, trim to frame to shorten a frame up to an existing frame, trim and extend using additional existing faces to shorten or extend existing members, lengthen, shorten. We can reuse and we can change, and we can also change individual members as we see fit as well. Further to that, we have things like the beam column calculator, where we can analyze the impact of what we're creating making sure that it will handle the loads that we intend to impose upon this structure. Frame Generator is a great feature of Inventor, allowing us to quickly create a structural frame, analyze its suitability for purpose, and quickly pass it on to production. When it comes to placing fasteners in an assembly, you can use the Content Center, which comes preloaded with well over 1 million different components. Within our frame assembly, I want to add a connection here of these two plates, which will be bolted in reality. You can see that Inventor intuitively resizes our part to suit the part location. Additionally, I can use a bolted connection to add multiple fastening features at once. I'm starting off with an M10 by 25 fastener. I can click to add a fastener, add some washers, add a locking nut, and you can see Inventor has intuitively upsized our fastener to suit the full connection. When I'm happy with that, I can either do a calculation on that specific connection, making sure that the connection I have specified is suitable for purpose. I can run fatigue calculations once I've made an initial calculation. I can continue to do this for all the locations along my part, and then throughout the assembly at each location it needs to be placed, or create a pattern of all the tools at the same time. And just like that, we have a connection using a bolt, washers and locking nut, all constrained and locked together, which can then be called up in a drawing, in a parts list, or exported spreadsheet of components. One of the biggest scenes of industry activity at the moment is the BIM movement. BIM, or Building Information Modeling, is a process involving the generation and management of digital representations of physical and functional characteristics of places. Many of our customers have enlisted in our help to radically reduce the complexity of their production-ready models from Inventor to a simple representation for Autodesk Revit, which contains all the proprietary information necessary to meet architectural protocols. The model I have here on screen is a very simple, when it comes to Inventor anyway, a very simple light switch model, which has a few features on it. Unfortunately, Revit doesn't like models such as this for a number of reasons. Things like the rib tool, the split tool, and the shell tool aren't known features inside Revit. The BIM tools in Inventor 2015 make this process significantly simpler by allowing us to remove complex modeling features which Revit struggles to recognize. So we can remove details, we can fill voids, we can define envelopes, all to reduce the complexity of this file and prepare it for export into Revit. This process reduces the file size, but it also includes aspects such as material, appearance, and descriptions, which can be then taken into the Revit file and exported directly from the BIM Exchange tools. We can check our design, make sure everything's okay. And we can export building components. From our experience here at Graitec Professional Services, I can advise using the ADSK export format for reliability and ease of use. There is slightly more work involved in Revit using this format, but the time gained through reliability is worth the initial time investment. Inventor has a number of ways to produce stunning visual representations of your models, from photorealistic renders using the realistic graphics and ray tracing settings, alongside perspective viewing environments to Inventor Studio, which can produce impressive rendered still images and moving animations. To display some of these, I'll use our cylinder assembly here. I'm currently looking at this in a perspective mode. A lot of users may use the standard orthographic mode, but when we start getting into visualizations, perspective makes it look more realistic. We can add features such as shadows, reflections, the ground plane if necessary, but not necessarily. We can even start looking at environments. Additionally, the realistic graphics mode with ray tracing enabled can create some fast rendered photorealistic imagery. As you can see from the image on your screen, using some of the advanced graphics modes in Inventor 2015 produces realistic imagery which is market ready and negates the need to invest in complicated rendering programs. This image rendered in just 29 seconds and can be quite quickly changed to omit things like reflections if we decide we don't want to use them, and re-rendered. And it's all it's taken us is about a minute. These files can then be exported as an image and saved for use in the marketing department or in brochures or featured on any websites. Additionally, we have something called Inventor Studio, which it offers more tools for creating visualizations and animations, provides quick and easy access to things like lighting styles, which we see here, scene styles, and also introduces things like cameras, local lights, and animation features. As you can see from this animation which I created a bit earlier, Inventor can handle multiple movements at once, can animate your assembly and show off the movements that you have specified. Using a combination of the tools shown here today, Inventor demonstrates why it is the prime choice for digital prototyping in the manufacturing industry. Inventor's capability to help you create digital representations of your products quickly and efficiently, test for structural suitability, and produce stunning visual imagery, reduces production costs and produces better products earlier in the process.